corrections for the coefficient of restitution calculations related to video number 4. So I have a table there at the top. Each of them was dropped from 60 inches. I'm just going to say it's a height of 60, it could be 60 centimeters. And then afterwards they raised to a particular height. So the basketball was dropped from 60 inches, bounced off the floor, and rebounded to around 38. The football dropped from 60, rebound to around 30, tennis ball rebound to 35, golf ball rebound to 40. So what you need to be able to do is understand how the velocity relates to the coefficient of restitution and how the displacement relates to the coefficient of restitution. So to the text, the box below, so the second box, recall that v squared is u squared plus 2as. If it falls, the acceleration is g. U is 0 if it falls, so v squared is equal to 2gs. And that means v is proportional to the square root of s. Now we know that E is equal to minus V over U. It would have made more sense if I had put E equal to minus V over U rather than what I have. And then because the V is proportional to the displacement under the square root, we can say that V over U is equal to the square root of S1 over S2. And I should really have there E is equal to the square root of minus S1 over S2. But we're going to take the absolute value because one of those displacements will be down, the other one will be up. One will be positive, the other one will be negative. So the minus that should be in that square root then is gotten rid of. So for ease of purpose, I get rid of the minus is there. So E will be just square root of S1 over S2. Calculation wise then, so for number 1, it's the square root of 38 over 60, works out as 0.8. Number 2, square root of 30 over 60, works out as 0.78, and so on and so forth. And those are the 4 calculations that I wanted you to do. Now, I have 3 additional questions, so take out a page and will you calculate the first 2 and answer what factors do you think influence the coefficient of restitution?